Welcome. In this video, I'm gonna teach you how to find the moment and center of mass of of a of an object modeled by a single point. So let's say that the mass is concentrated on a point. We call this point X. Call this point X. And then so the mass so the mass is concentrated on that point. So people usually confuse what mass and weight are, but but the difference between mass and weight is that mass is a quantity and weight is a force. So usually mass is measured in kilograms or grams, and weight is usually a force. So that's the big difference. Sometimes they are used interchangeably, but that's not correct. In physics, there exists a problem where you have a seesaw. So you have a table, piece of wood, and then in the middle you have a fulcrum, and then here you may have a box, a small box, and a big box. So let's call this one M1. So the mass of the small box is M1 and the mass of the big box is M2. So what moment tells us is that the moment is equal to, so moment, we call it moment is equal to each little mass multiplied by the distance between the origin and the object. So this here, it's P1, we call it, let's call it P1, and here we call it P2. So the moment is going to equal to, for this particular example of the seesaw, we're going to call it M1 times P1 plus M2 times P2. So this is your moment. And then the center of mass is gonna be when you modify P1, the distance between the origin, the middle, and each object, when the sum of each moment is equal to 0. That's the center of the mass. That means that the system that we're talking about is in equilibrium. Okay, so sometimes to get to that equilibrium, we have to modify this formula. So let's say that let's say that we want to find the center of mass. So that means that we have to shift each object in the seesaw or the system by a unit, by an x unit, by a horizontal unit. And we call that horizontal unit x bar. It's a horizontal shift. That means that your xi is gonna be equal to x minus x bar, because we're shifting either to the left or to the right, each object in the seesaw. Okay, that means that each hero moment is equal to the mass times the shift, the horizontal shift, and then your total moment becomes so let's say you have n objects, each with a mass, and then the horizontal shift. So this is your moment. So this includes the shift. And remember, to find the center of mass, we said is equal to 0. That means we need to find x bar. That will give us the center of mass. So if we solve the equation by x bar, we're gonna find that so we'll multiply mi times xi, and that gives us the top. Then we'll multiply mi times x bar. Move it to the other side. So for x, we get this here. That means that for the center of mass to be in equilibrium, then this here has to be 0. The top part has to be 0. And that will be your center of mass. If you want it to be in equilibrium. So equilibrium means that the top has to be in 0. Thank you very much. Don't forget to subscribe, please.